Can you take your seats, please, ladies and gentlemen? Okay, we're about to kick off, so please take your seats if you can. Jez will come first and then... Okay, well, welcome back everybody to the next session. This is a really important part of the day because this is where we're going to get our update on a lot of the work that's going on research, development and innovation. So we've got a couple of separate sessions here. Jez and Jen are going to talk about OFWAT and acoustic research initiatives. Then we've got a session on the National Leakage Research and Test Centre, and then something about pipe innovation and prevention of leaks and repair technology, which, as we heard earlier from Joe, is a bit of a gap in our expertise and knowledge at the moment. So I'm not going to introduce Jeremy to you because I'm sure you all know him extremely well. So for the first session, over to you, Jez.
Yeah, thanks, Bob. That's frightening, isn't it, when you're just, I don't need to introduce. For some of you won't know me, so I'm Jeremy Heath from SES Water. As Kieran Brocklebank from UU christened me recently at a conference, I'm Jez from SES. Yeah, thanks, Kieran. Can I just start by thanking Judith? It's absolutely wonderful to be talking to everybody in the morning. Generally, they stick me on directly after lunch with a view that my job is to wake the conference up again. So it's really nice to be able to speak to you in the morning. So look, what we're going to do is I'm going to be going through the UKWIR program, what the projects are at the moment, and a brief explanation of that, where we're going. If you've got questions, I'm not going to do them at the end. Okay, so if you've got a question as we're going through, just shout out, "Oi, Jez." Okay, and we'll pause at that point and I'll go through. So let's pick the questions up as we go through. So the UKWIR program, okay, the UKWIR route map's been out there for a long period of time now. Some 6 months ago, I was sat up on stage and we were going through the Water UK route map and people were going, okay, what does this mean for the UKWIR program? And I said, when I was interviewed on stage, it means that we're going to have to update, okay, and revise that entire program. And a number of you sat there, looked at me and said, yeah, when you get round to it, Jez. So the good news is, it's happened. I love that expectant pause. It has happened. We have updated the route map. Now, some of you will have seen it already. It's up on the UKWIR website, but some of you won't. And look, you know, let's be honest, I'm not expecting a round of applause here, but can I have at least maybe some astonished gasps at the audacity and work that we have done? Oh, fantastic. Lovely. Okay. There is actually a lot going on here, so I'm just going to briefly take you through what's going on. It's available on the UKWIR website. Please do go and have a look at it. So this is the research program from the water companies. Some of you wondering who UKWIR are. UK Water Industry Research. It's a jointly funded body from all of the water companies coming together and saying, this is where we do our research, and I'm the program lead. I make sure that we're kind of listening to the industry and reflecting where the research needs are. So, number one is a very, very simple change. I'm just going to wander over here. Very simple change. I've put numbers on it. So previously, all of these that you saw on there had a little number on it. You can see the top ones up here, 36, 37 and such like. And you always said, what on earth do those numbers mean? And it was just simply a number, little placeholder. What I've now done is put the report numbers down. So as soon as the report is published, it's there. It just makes it easier for everybody to find. But the massive, great big change that some of you are going, I can't believe you've done that, is that we have changed all of the outcomes going across the top. Okay, so everything is now badged under PALM. Prevent, aware, locate, and mend. We coined that phrase about 5 or 6 years ago at this very conference. We started talking about PALM. PALM is now a way that the whole industry reflects upon managing leakage. And so what we've done is we've taken the route map and just aligned it into that. So everything falls under those categories, and it makes it a lot easier when we work our way through. The other great bit is I've made sure that all of the projects are on there. So previously, some of the projects were kind of put together. I've made sure each project now is badged separately. And what that means is, for the first time, I can show how many projects we've done. There are 15 blue projects in there. That is a testament to you lot. Particularly to all of you in the water companies who are providing staff to sit on program steering groups and managing those projects and making sure the results reflect what we're looking at in the water industry. So I'd like to say thank you to every water company that is providing members of staff to sit on those program steering groups. It's extremely important. We have done more projects than any other big question. When I showed this recently in front of all of the other program leads, they actually did do a gasp as well, because they were looking at our program and going, my word, you have done so much. But not only have we done so much, we are doing so much. We have 11 live projects running at the moment. A number of those are fundamental research with universities, and we're going to be hearing from Jen from Southampton, who's managing a lot of those. But we've got 11 projects, so there's a lot of work going on as well. So look, what I'm going to quickly do is just dive through the live projects that we've going on so that people are aware of what we're doing, and we'll work our way through in order. So let's kind of start with the prevent side over there. Okay. We have been really focusing, and it's really great seeing so many people coming into this room now who are looking at preventing leaks occurring in the first place. Okay, it's about calm networks, it's about our mains replacement programs, about all of those things. So what we're looking at is we've got a couple of PhDs working at Sheffield University, looking at the impact of pressure transients. We did a great piece of work recently where effectively we looked at what causes pressure transients in our networks, able to demonstrate really well where those were coming from, that 60% of our pressure transients were associated with pressure changes, but 40% weren't. There's a large number of transients that aren't pumps going on and off in our network. Okay, caused by other reasons. Now what we're doing is taking that piece of work, handing that to a PhD and going, okay, what does that do to the pipes? What does it do when we've got the pipes flexing all the time with these pressure transients going on? And then a second piece of work there, looking at the deterioration of cast iron as well. So looking at the stress rises that that's causing and how, particularly with cast iron, that's affecting it and causing that long-term damage that we're seeing, how leaks are growing. So that's going on at Sheffield at the moment, two great pieces of work there. And then we got some ones from Southampton, tracking pipeline fault progression. I'm not going to talk about the Southampton ones because Jen is coming on video. So she's going to be talking about those bits. So then we've got assessing levels of leakage on new polyethylene networks. Yeah. Now we've already been talking about that today. Yeah, in fact, I stuck a little post-it. I'm hoping everybody has written down some post-its, okay? Get your post-its up, put them up on the board there. Okay, but my one that I stuck up on there is, can we install new plastic pipe that doesn't leak? I was in Germany about a month and a half ago, chatting with German water companies. And I asked them about leaks on new pipes, and they just went, what exactly do you mean? And it took some time to explain that I wanted to know how many times their new pipes leaked. And they basically just had no understanding of that whatsoever because their pipes don't leak. Ours do. We have good anecdotal evidence of that. John, I know you're in the room somewhere from Anthire, has really good evidence of that as well. What this study is doing is effectively going into brand new networks that are laid on brand new estates and saying, okay, let's assess the level of leakage on those new networks, because we need to understand the size of the problem. But this is one of those pieces of work that is a springboard, meaning the outputs from this will then start to drive changes. Because we will need to then say, how do we make sure that our contractors, that all of our systems that are being laid on those new estates are laid correctly, but not just the new estates, every mains replacement as well. We can't be laying plastic that leaks. So that's a bit of springboard work that we're doing there at the moment. So that's the prevent piece. So pretty clear, I think, hopefully in terms of that side, but let's look at AWARE. Let's look at AWARE. Now, previously, when I talked about AWARE, when we talked about PALM, we thought of awareness as being which DMA are you going to go and work in today, okay? I've expanded the scope of that a bit, okay? Let me explain why. So I do like watching my YouTube videos. My son and I basically sit down in the evenings and have a cast-a-thon where we try and find funny videos to make the other person laugh. We almost inevitably come down to bike crashes at the end. But one of the videos that I showed recently was Rowan Atkinson. Now, Rowan Atkinson does a wonderful sketch where he plays the part of Sir Marcus Browning, MP, and he does this amazing speech, as Rowan Atkinson does, which basically says absolutely nothing and just speaks in platitudes. But he finishes it with a great line, which for me summarizes leak awareness. Rowan Atkinson says, "Because we don't want to be like the blind man in a dark room looking for a black cat that isn't really there." That is leak awareness. We don't want to be in the dark looking for black cats that aren't actually there. It's not just about which DMA you're working in, it's also about which component of leakage: trunk main, distribution, supply side, plumbing losses. Where is our leakage occurring? You'll be hearing as we go through today a lot of work that's going on trying to do that quantification. Where is leakage happening? And that's what fits into awareness. So think of awareness not just as in geographically where, but where in the components of leakage. Because if we don't understand that, we are looking in dark rooms for black cats that may not be there. So, projects we got going on in that. We have an update on non-acoustic leak detection. We did a project about 6 years ago where we looked at leak detection techniques that weren't relying on acoustics. Really interesting, that discussion this morning about listening sticks. Totally agree. Part of the problem that we've got is people are going, there is no leak because I cannot hear it. But there are other ways of detecting leakage. Yep, I'm aware of my time. I know, I've got to keep going. Okay, other ways of detecting leakage, and we're dealing with those ones. So that's the non-acoustic leak detection one. It's an update of that, looking at all the modern methods coming through. And then the other one we got in there is a deep dive into leakage. Okay, deep dive into leakage, effectively looking at top down and bottom up and going, can we reconcile the two? Now where we've got DMAs that have got loads and loads of smart meters in there, can we start to do that water balance both ways? So I've got Doug. Doug, are you in the room? Fantastic. Doug, can you just stand up? So Doug's working on that one. Now, the reason I wanted Doug to stand up as well is because Doug is doing another important piece of work. We talk about collaboration. 3 years ago, we asked you all to share your research plans and what you're working on innovation and leakage, and every company stepped up and shared what they were doing. 328 projects shared across the industry. Fantastic, because that is collaboration. That's what we're doing really well, saying these are the projects we're working on. Doug is doing an update on that, so that will be coming out probably in the next 3 to 6 months. Doug will be saying, here's an update on the leakage innovation heat map. So that's the work that's going on at the moment. The location stuff, Jen's going to talk about in a second, and MEND is an area that we're slowly developing at the moment. You can see I've already started to get some projects in there. What I'm not going to talk about is all the ideas we're working on at the moment, but you will start to see new projects coming through from UKWIR and also from suggestions as well, so we can start to build that plan up. What I'm going to do now is pause. Thank you, Bob. And I'm going to pause now, and we're going to go over to video. We've got Jen, and Jen is going to talk about the projects that are going on at Southampton. So with a bit of luck, I can stop talking, sit down for a second, and Jen will appear on the screens magically behind me. And there she is, wonderful.
My name is Dr. Jen Muggleton. I'm from the Institute of Sound and Vibration Research at the University of Southampton. I'm delighted to be here with you this morning and talk to you about some work that we've been doing with UK water industry research on acoustic and vibrational methods for leak detection. We've been working with UKWIR for a number of years on a range of projects, and last time I spoke to you earlier in the year, I talked about a project on leak noise characterization, a PhD project. This time I'm going to talk about 4 PhD projects that are all running at the moment, all in different stages of progression, and these are the ones highlighted in green on the slide. Combining transient and steady state signal processing methods, which started in 2018 and is nearing completion now. Pipe wave modeling, which started in 2020 and we're about halfway through. Signal processing for distributed acoustic sensing, which started last year, so we're just 1 year in. And then leak to burst leak noise characterization, which started just a couple of months ago. So this first project I'm going to talk to you about this morning, combining transient and steady state signal processing, is, as I said, nearing completion. And it really has 4 elements as set out in the slide. Examination of the roles and potentials of steady state and transient methods, developing a framework for the simultaneous application of those methods, improving cross-correlation by directly estimating the wave speed, because we know that one of the limitations on the cross-correlation method is that quite often we don't know the wave speed accurately. And then looking at alternatives to cross-correlation time delay estimation suitable for transient signals. Focusing on just 2 of those 4 elements, firstly, the direct estimation of wave speed. The student has investigated 2 potential methods. One is exploiting reflections using a Sepstrom analysis, which is a nonlinear analysis, and the other is using blind channel estimation, which is a statistical method for working out the propagation characteristics and hence the wave speed. He's done some numerical modelling, he's performed some experiments, and both those methods look extremely promising. The second is looking at alternative time delay estimation methods. He's looked at wavelet transform methods, data adaptive methods and differential methods. And again, all of those show some considerable promise. His thesis will be due out in the coming months, so I'd be very happy to share that once he has completed his Viva. So moving on to the pipe wave modelling project. If we want to detect a leak by using its acoustic signature, one of the important things that we need to know is how that leak noise will propagate along the pipe. Now we know that most of the energy propagates along in what we call the fluid-dominated mode, and we've already done considerable work on that. It's an axisymmetric mode. We know the wave speed, dependent on the pipe properties and the soil properties, and we can predict the attenuation. But we also know that near joints and bends, mode conversion can take place. And it's at those very joints and bends, particularly like hydrants, where we try and pick up the acoustic signature. So the aim here is to look at the potential of exploiting these higher order modes, and particularly what we're calling the fundamental flexural mode, which is the simple bending wave in the pipe. So we're looking to determine the dispersion characteristics, in other words, the wave speed and attenuation, for a pipe in vacuo to begin with, because that's the simplest model, then submerged and then buried, and then supporting that with laboratory and field experiments. So how are we progressing on this project? Well, as I mentioned at the beginning of this presentation, we're about halfway through the timeline. So first of all, we've done some analytical modelling for an in vacuo pipe, both an empty pipe to begin with and then a fluid-filled pipe, water-filled pipe. And we've supported that with experimental measurements in the laboratory. So here in this top graph, you can see the dispersion relationship for an empty pipe. The blue are the measurements in the lab and the red is the prediction. And we have wave number versus frequency. Wave number is related to wave speed. And as you see, the red line here is the analytical modeling, and the blue is the experiment. And at low frequencies, there's very good agreement. What we find here at higher frequencies is we get another mode cutting on, which isn't of major interest at this point. Below here, we have the same thing for the fluid-filled pipe. And what we see is the wave number increases slightly, which means the wave speed goes down. So what we see is the water inside the pipe slightly lowering the wave speed. And again, we have fairly good agreement between measurements and predictions. We're now starting to move on to submerged pipe. We have an analytical model for that. And what we find there, again, is that the water outside the pipe effectively adds mass to the pipe, so the wave speed lowers again. The student is currently performing experiments in a tank at the university, and we'll have the results of those soon. We're also at the same time looking to develop analytical modeling for the buried case, but at the same time it's a very complex problem, so the student is starting to do some numerical modeling of that. And we're planning some experiments in a new pipe rig that we've developed at the university, which we hope to be working by the new year. So moving on to signal processing for distributed acoustic sensing. This project, as in the title, is a signal processing project, and it really supports configurations in which data from more than 2 sensors might be available. For example, when you have optical fibers, perhaps picking up the leak noise, distributed data loggers, or possibly other more closely spaced sensors than we might have in a normal cross-correlation situation. Normally, when we do cross-correlation, we get information about time delay from just a single pair of signals, so from two locations. But in fact, cross-correlation can be generalized to any number of sensors. And this is what we're looking at here. So as I said earlier, we're about 1 year into this project, which is a 3.5-year PhD program, which all our PhDs are these days. And what the student has done is he's developed a multi-sensor matrix formulation for cross-correlation, where basically all the different possible pairs of sensors for a multiple sensor array are considered. He's looked at the effect of sensor spacing and regularity. He's looked at the effects of background noise. He's looked at the effects of multiple leaks and how that might manifest. And also he's looked at what happens when you have reflections in the system. Here on the top left, you have one example where he has shown amplitude of the resultant signal for 3 different leak positions. We have here 3 leaks shown with the red dotted lines. He has an array of a number of sensors along the pipe, along in this case a kilometer of pipe, and the black line represents the final image signal, and as you can see, it aligns very well with the actual leak position. So this is really very promising. To confirm what he's developed theoretically, he's in the process of developing some laboratory experiments. The final project I'm going to talk to you about today, we're calling Leak to Burst Leak Noise Characterization. And the idea here is to see if we can trace the progression of a leak to a burst by examining its acoustic signature only. This project commenced in November this year, so it's only just started. It's one part of a 2-part project, the other part looking more at the corrosion side of the work rather than the acoustic signature side. We're focusing on cast iron trunk mains. We know from our previous work on the other project, the leak noise characterization project, that the majority of the leak noise is generated around the perimeter of a leak. So this is where we're focusing our attention on. We're planning to develop or progress our numerical model. We're going to undertake some scale laboratory experiments to examine the turbulence across a leak along with leak noise. And we're going to undertake flow visualization experiments. Of course, we will integrate with the sister project on corrosion, as that project will hopefully give us an idea of the kind of shapes and of leak that we're to expect, depending on the initial damage to the pipe, whether it's corrosion, pitting, or a small split. As I'm sure you can imagine, we've only had a month or so on this, so there really isn't very much to report on progress, but that gives you an idea of what we're hoping to achieve. Before I finish today, I'd like to draw your attention to 3 other PhD projects which were on my initial slide, which we're now advertising to attract students to. The first is hydrant dynamics for acoustic leak detection. How can the dynamics of a hydrant, which is quite often where we do the acoustic sensing, the vibration sensing, how can the dynamics affect what we pick up? And can we optimize sensor placing, sensor orientation to get the best signal that we can? The second is optical fiber sensing for pipeline leak detection, looking at how the acoustic vibration signal from the pipe might propagate through the soil to an adjacent optical fiber. What kind of offset can we tolerate? What kind of soil conditions and what kind of sensitivities are we likely to get? And then finally, acoustic rods for closely spaced pipeline sensing. This is looking at inserting fine metal rods into the ground where one end touches the pipe and the other end comes to the ground surface, so that we have basically vibration coupling between the pipe and the ground surface, which would enable us to do more closely spaced monitoring than we currently can by only looking at hydrant locations. Students must have a good undergraduate degree in engineering, maths or physics, but relevant industrial experience may count in lieu. All our projects are 3.5 years full-time or 7 years part-time. They're all advertised currently on findphd.com and also jobs.ac.uk. If any of you out there are interested, do have a look. Just put my name, Muggleton, into the search box and all these projects will come up, or do feel free to contact me directly. It just remains for me to thank the 4 academics who co-supervise these projects with me, the 4 students who are undertaking the work, and of course the funders, UK Water Industry Research, particularly Jeremy Heath and Dennis Dello, and of course the EPSRC, who co-fund the projects. So thank you very much for your attention. I believe we have some time for questions, and I'm here live via Teams. I think Jeremy has possibly some questions lined up for me. And also there are my contact details should anyone wish to get in touch with me.
Thank you very much, Jen. Can we actually just have a round of applause for Jen there? Jen, earlier in our session here, somebody made a comment and said there is a perception that the UK are behind the curve in terms of our leak location because we continually see pictures of our inspectors holding wooden rods to their ears to try and make best understanding of the sound to find a leak. What's really interesting is we've just had that view completely blown out of the water. We have got some of the most incredible research going on at the moment to tell us what's going on with these leaks, to help us find and locate them in a way that nobody else in the world will be able to do. So really fantastic research, Jen. Jen, can I just touch upon one that I think is really interesting, is that last project you were talking about, which is that how that sound of a leak grows, okay, of how that changes. That's something that's a little bit of a kind of golden egg for everybody here, because we all get these noises of a leak, but we don't know what they actually mean, and we don't know what that tells us about the leak. How do you see that project developing, and what do you see as the outcomes coming from there?
Well, I think what we found in the previous project is really important here, which, as I said in the presentation, we now know that most of the leak noise comes from the perimeter of a leak. So whilst the amount of water that you lose will come from the cross-sectional area of the leak, the noise comes from the perimeter. So if you have something like a split, you may not get much water loss, but you get a big noise. Whereas if you have something like a hole, you'll get more water loss, but perhaps a smaller noise because the perimeter is that much smaller. But what we're seeing, I think, what we will see with this project is in cast iron pipes, what we believe happens is a number of corrosion pits weaken the pipe, and then some external event will cause catastrophic failure of the pipe. So what we will, I think, be able to look at is what happens if we have one leak that then changes into multiple leaks, what happens to the noise there, or potentially what happens if you have a small split and the split gets longer, what will happen, proportionately to the volume flow through the leak and the leak noise itself, or alternatively what happens to a split if it doesn't get longer but it gets wider. So, I mean, there's potential here for really remotely tracking the progress of something here. And whilst one single measurement may not give us a huge amount of information, the important thing here is tracking it over time will give us considerably more.
Jen, thank you. That's really great. One of the things I will say as well is what we're doing with the PhDs is you saw that typically those will be 3.5 years. So what we don't want to do is wait 3.5 years for those results to come out, and that's the only time you hear what's going on. So what we do with the PhDs is that every year they provide a quick summary of what they've found so far, so we get any learning that's happening out to you guys, out to everybody in the industry there, so you're at least getting some understanding of where this is going. Jen, we're going to have to call it short there, I think, in terms of time now. I can see Bob nodding. Thank you very much, Jen. Fantastic. Can you thank all the students working on that? Thank you so much as well for the UKWIR program that everybody, you know, from the water companies, and I know also supply chain get involved as well. Can I thank everybody for their involvement and engagement with this research in the water industry? Bob, back to you.
Thank you very much.
Jez, there was a question that came through on the Slido there, just asking about how people could get hold of that stuff, as you mentioned at the end. Will that be published as part of the pack after the conference?
Yeah, so what we do is we'll make sure that goes up on the UKWIR site. So I'll direct everybody to the UKWIR site. Go and have a look there. We'll make sure that's up on there for people to see as a review as well.
Great, really interesting. Thanks very much to you both. So moving on quickly, we've got a session now in a slight change to the published programme from Andrew Blenkarn, who is a technical policy manager at Northumbrian Water, and he's going to talk about the National Leakage Research and Test Centre, which is an OFWAT Innovation Fund winner. Andrew, there he is.
Morning, everyone. Thank you very much. I was supposed to be presenting with my colleague from the innovation team, Clive Sermon-Wells, but unfortunately he tested positive for COVID yesterday, so I've been left to kind of fumble my way through all this presentation. So apologies, the second half might be a little bit ad hoc. I'll just start off why we need a National Leakage Research and Test Centre. So I don't think I need to tell the people in this room the challenges we've got with the leakage over the next 20 to 25 years. We've mentioned the innovation heat map a few times already, and the gap that we kind of see there on repair technologies and the potential that we need to do something in that area. So when I was initially talking to Clive about this a couple of years ago for an OFWAT bid, I was very much looking for, you know, potential solutions. Where do we want to put some money where we can really develop some of this stuff? And Clive kind of turned it on its head, and he said, really, actually, rather than trying to pick something that we're going to put all our eggs into one basket, we need a facility where we can encourage innovators and creative people to come in and test new technologies and really kind of speed up the innovation process. So that's the kind of angle that we've looked at in terms of the current innovation journey. So at the moment, someone will have an idea and an innovator will kind of test that within the garage or in the garden. They'll get it to a certain point where they believe they've got something worth following up on. So at that point, they'll probably kind of engage with a company, tends to be, you know, a local company or where they might have contacts. And they might be able to do some testing on one of the training rigs. A lot of the companies have a small scale training rig now. So you could do some limited tests on that. You might get it a little bit further. But before you can get it into the live network, you obviously have to get kind of the DWI Reg 31 approval. So that can be a really long process, can be months or years until you're able to put it into the live network. And then at that point, you might get it in the network and suddenly it doesn't react how you expected, or it might come across other problems when you have kind of customer supplies and kind of valves and everything else on there. So you might have to go around the circle again and kind of go through developing further before you come back into the network. And then you get to the stage where you want to go out to the market, and every company will want to test it themselves, see how it works on their own network. So then you've got to do that multiple times, and eventually, you know, if it works, everyone's happy, it might kind of go out to the market and be successful. But that could take a long time. So the idea with the National Centre is that, you know, you're still going to get those good ideas, the development within the garage, and then at that point, we're hoping that they'll be able to come to the test centre to be able to use the facilities while they're doing the Reg 31 approval. And at some point, we might even be able to kind of get that testing, the Reg 31 approvals through the test centre as well, so it's all linked in together. So yeah, the idea is that you're progressing these works together, you're developing, you really understand that the network's as close to real life as possible, so you're coming across those challenges within the development, you're solving them while you're getting your approvals and things like that. And then at that point, once you know it works, you've had the involvement of the companies throughout that, so that all the data is shared, everyone's involved in kind of the tests that we're doing and the results that we get. So once you know it works, everyone has the confidence then that this is something that we can apply and we can really get out in the market much quicker and get it adopted. So we're really looking to kind of reduce the speed of that innovation. So these are the key objectives. It's really about enabling more innovation, like I say, in the field of leakage, and we've got on there the PALM acronym. It's not just about that repair side, it's across all elements. It's a fail-safe environment to really accelerate this development. So we want to speed up, we want to get more people in, we want to get it moving quicker. We want it to be as close to real life as possible, because that's the idea. You can test it in this facility and then you've got the confidence to go into the live network straight away. And then hopefully, yeah, with the accreditation, whether that is the DWI approval or whether that's just kind of it's been through the test centre and it gets that stamp of approval, hopefully it's going to give the confidence to companies that it's ready to be used. So there's a lot of companies involved. It's a big project. I think in total it's around £6 million bid. I think 5.3 million of that is provided from the OFWAT fund. You can see we've got most of the water and sewage companies involved in this, so it is kind of got really good backing around the industry. We've got the main research establishments on there. We've got WRC, HR Wallingford and Isle Utilities, so they're helping support the design and the actual construction and kind of the running of the facility going forward as well. We've got British Water involved. I think that's to really try and get kind of the awareness to suppliers and get them involved as much as possible. And then we have kind of the university. So we've got Southampton, just heard from Jen there, and then University of Sheffield, Joby Boxall, who you'll probably all be aware from UKWIR projects and things in the past. So we've got a really, really good team behind it, and yeah, really good backing, which is great. Now at this point, Clive was going to go through some of the features, so I'm not kind of very familiar with the things that we've got, but this is just a bit of an overview of kind of the schematic and what our current thinking is on what's going to be at the facility. So we're looking at a network around 5 kilometres long, so quite a substantial amount of pipe work. I think it's going to be on we haven't decided on the site yet, but it'll be kind of on a neutral kind of site where we can kind of get good access for as many people as possible. It'll mainly be buried pipe. We're going to have all different types of pipe materials and diameters, and we're hopefully going to have a mix of kind of new pipe and also kind of exhumed pipes, so things that are already failing, kind of put them in to see how that affects the technologies. There's going to be all kinds of valves, so we'll be able to kind of rezone, isolate sections, be able to do kind of lots of different tests. It's going to be highly sensorized, so obviously we can collect the data, we can monitor what's happening, we can really understand kind of every data point, I suppose, on that network. So the next key feature is about having kind of configurable leaks. So the idea is that we can kind of define kind of where leaks are and what leaks are running at different times at different parts. So if you get a supplier coming in and kind of you don't want them to have the same leak in the same place, it's not going to really test anything, is it? So we want to be able to move those around. And yeah, we don't want them to know where they are, so we can really test that, and we can kind of run lots of different scenarios. And then it's got to be kind of water efficient. We can't just have this water leaking away and disappearing out in there. So it's all kind of self-contained. All the leaks that are generated are then going to be collected. The water's collected, it's recycled, then back through the facility. So yeah, nothing's wasted. It's not leaking away. We're going to have some water storage on site, and the idea of that is it's going to be isolated from the live network, obviously, so that we don't get any kind of backfeed into the live system or anything like that. So it's going to be a completely isolated system, which is going to be pumped to make sure we kind of get network pressures representative of the live network. There's going to be a control room on site. So the idea is that there's going to be, at the moment, the plan is for 3 full-time staff. There'll be a centre manager who's going to be involved in kind of organising who's in and when and what's going to be the priority for like which projects we're going to be doing at each time. There's going to be a researcher kind of developing, I think maybe a PhD student, I believe, going to be kind of working on site. And then there's going to be a technician as well for doing the valve and the actual operation of the network. So I think that's going to be kind of from opening, we've got that for a set period of time as part of the project. I think there's kind of longer term decisions to be made how it's going to be run in the longer term future. So I mentioned before, we're hoping to kind of have some certification involved in this. So you want that stamp of approval. It's been through the test centre. We've kind of all signed up to it. We've agreed this works now, and we've got the confidence for them to take it out into the industry. There's been talk about whether we could use it as a training centre as well for the different technologies, but the focus is very much on kind of promoting innovation and trying to get that to progress as quickly as possible. Finally, I think we're also wanting to try and include some customer demands. So I think with the team at Sheffield are going to look at kind of some algorithms and stuff for generating a kind of demand profile. So we are really trying to represent what's happening on the network kind of day in, day out. So these technologies are really having to work hard to kind of deliver against those challenging conditions, so what the impact on customer supply pipes and things like that. And again, the water from that's going to get recycled back through the system, so nothing will be lost. In terms of a delivery plan, we're in the very early days at the moment, so I think the first 2 workshops have happened on the operating model and the governance, kind of get that, I suppose, very important, not quite as exciting stuff out the way early doors, but we're definitely entering into the phase now where we really want to encourage kind of the involvement from as many people in this room as possible. We'll kind of be doing more of the specifications, so get into detail of what size pipes, what materials, how is it going to work, all that kind of stuff, which I think everyone will be really keen to get involved in, and we really would encourage everybody to get involved. So we have got a stand outside. Dan's been manning that in the kind of networking sessions. Please pick up a leaflet. There's a QR code on there to take you to a website. I think you can register details, kind of get updates and things like that. So there will be more workshops coming very shortly as we go through the various processes. But it is quite a long project. As you can imagine, there's a lot of planning that needs to go into the design work and then actually construction. So at the moment, we're looking at about May 2025. So it is kind of a long-term project before we kind of get it up and running and then kind of invite innovators in. But yeah, I think that's everything really. I just encourage you to come and speak to us, get your name down, register your interest, and get involved to really help us steer where this is going over the next couple of years. Okay. Thank you. I'll try my best. Yeah.
Any questions for Andrew? Didn't he do a great job standing in for his colleagues? Well done. Any questions? There's one here in the middle.
Has any thought been given to how you'll get the water companies to buy in and take any solutions which will end up having the accreditation? So the whole perspective from the supply chain to go through the test centre would be to try and shortcut that journey that we have to go through individually with water utilities. We'd need some sort of framework or assurances or guarantees that if we get an accreditation that we can go and walk into a water utility and they don't turn around and say, oh yes, you've got that accreditation, but it doesn't suit our network.
Yeah, it's a difficult one, isn't it? I mean, say fundamentally, that's what we're really trying to achieve. Will companies still have that confidence from doing our test work? I mean, the idea is, so we're getting early engagement. We want people to kind of be involved in setting up that network so that when we do the testing and once it's been through that, and if you do get that stamp, then you hope everybody has signed up to that. But yeah, there's absolutely, it's still a test centre, isn't it? So I don't know if you... I mean,
perhaps rather than hoping, maybe we can try and create some sort of framework with the water utilities as part of these early sort of operating model planning stages.
Yeah, I think that's very much been a part of the workshops in terms of the governance and what it's going to deliver. Are we going to get companies signed up to that? Yeah.
I just had one other question as well. Do you know whether multiple solutions are likely going to be undertaken and being tested at any one time on the network? Is there likely going to be a big queue of suppliers and solutions waiting to get onto the network? Because if the lead times are too long, then again, people might just find it easier to try and go through the arduous journey of going through the water utilities.
Yeah, absolutely. I think the hope is it's going to be flexible enough, and again, we're going to go through those kind of specifications of what we expect. But at this stage, I think you want to be able to do multiple tests, and that's going to be down to the centre manager to understand what the requirements are for the different projects. We don't want it to be like a block booking. A big company comes in, right, we're going to use this for 6 months. We don't want to kind of block that out and have the queue. So it's going to have to be flexible to be able to use different parts. You need to be able to come back to some of it years later because you need longevity in some of these things to really understand how they perform over time.
Yeah, we'll have to look at some of the IPR and data sharing side of things as well as part of that.
Yeah.
It sounds like you two need to have a conversation over
So get your name down, get involved in the workshops, please.
So I think there was one more question sort of towards the back in the middle there, or maybe, there we go.
Very much one of the next phases of moving here is around working with more so we are very much being working together to gain support from all of the
Okay, I think we've got time for one more, if it's a brief question at the front here.
A brief one, yes. Hi, Graham Jeremy, National Competence Centre. I just wondered if you've put any thought into the long-term sustainability of the centre. Once you've set it up, what's the ownership model going to look like, and how will continuous business be brought in, business development being done in that space?
Yeah, I think there's been some initial discussions. I mean, as part of the bid, I believe there is kind of it's covered for a certain amount of time, whether it's like 3 years or something like that. So there's certainly in the short term that's kind of under control. I think that, yeah, there's still got to be a decision made on who runs it, how it's run kind of going forward. But I suppose that depends on the success of it as well, doesn't it? Kind of if it delivers what we hope, then it'll kind of continue and it'll kind of take on its own kind of life. But we had a bit of a discussion yesterday in like the Leakage Network meeting around kind of where that centre is for all the research, all the things that are going on at the minute. It kind of needs to be a home for that, and possibly the test centre could kind of be that vehicle to make sure we kind of look after it. So I do hope it continues and takes on a kind of life of its own going forward.
Yeah.
Right. Great, thanks very much indeed, Andrew.
Thank you.
Before we move on to the next session, just a quick housekeeping point. How's the temperature? Could we do something about that, Judith? I think it's the AC is freezing us to death. Maybe there's a direct connection with the outside world or something. Okay. So we've got a multi-speaker session now, just to bring us up to lunch for the next hour or so. So this is around the topic of pipes and innovation around that particular area, which, as we heard earlier, is a key area we need to evolve and develop in. So firstly, on designer pipeliners, we've got Katrina Flavel, who is a technical specialist on clean water networks, asset strategy and policy at Yorkshire Water. And then Joe Sanders, who has a much more efficient job title of Technical Director of RPS. So Katrina and Joe to kick things off on designer pipeliners. That's another OFWAT Innovation Fund winner. Then Ian Robinson is going to talk to us about in situ resin lining. He's a director of Robinson and a consultant with Resin Line. And then we've got a third paper from Leo Fern, who is head of leakage strategy and projects at Hydrosave, innovation in MEND, targeted low dig background leakage repair, another really, really key area. So could maybe all the speakers for this session could come and join me here on the stage, and then you can be almost continuous.
They say start them young, but I'm perhaps taking it to the extreme today. So we'll indoctrinate this little one into the world of leakage. It's my last week before maternity leave, so it's nice to go out on a high. So I'm Katrina Flavel, I'm from the innovation team at Yorkshire Water. I look after our projects within the Clean Water Network. My background is as a materials scientist, as is Joe's, and that perhaps explains a little bit why we're so passionate about this project that I'm presenting to you today. So I'm going to have a chat to you about Designer Liner. I'm going to walk you through some of the history of the project. Joe's going to talk a bit about phase 2 and how we're going to deliver that, hopefully, if we're successful in winning a bid. And then there's an opportunity at the end to get involved, because as we've seen so much today, it's all about the collaboration that makes this work really, really well. So what I hope to get out of today is I want you to provide you with a current overview of the challenges around lining. I think quite a few of you will be familiar with this, but if you're not, it's a good introduction. I want to present Designer Liner as an opportunity to address these challenges. There's always the opportunity for high-level feedback. Please do ask questions at the end of the session and have a chat with us over lunch. The team is here. And then finally, the opportunity to engage with the project. So what's the problem with current lining, and where are the opportunities? So if you're a lining manufacturer in the room, I'm not here to knock what you're doing. What you're doing is great. We have some fantastic lining solutions available to us that do wonderful things, and you operate in a really difficult market in the UK. But we probably need to move beyond where we are, because we do have some challenges, and the OFWAT Innovation Fund potentially offers a good opportunity for that. So if we think about regulation, we've talked a lot today about how highly regulated the UK market is. That's really good for our customers in some respects. We want high quality drinking water. We want assets with a nice long lifespan. We want good value for money for our customers. But I think if you are a supplier in the lining market, that's really hard, and it makes the UK quite an unattractive market to enter. We've had conversations with the DWI and with OFWAT about this challenge, but we feel that as an industry, we perhaps need to do a little bit more to support that. I'll come back to cost. Testing. There's currently no consistent and robust testing approach for lining materials. We have some approved products, we have some international standards, we've had an UKWIR project to look at lining testing, and we have Regulation 31. But there's nothing really that talks about the fitness for purpose for material. So we had a question a few minutes ago about when you approach a new water company, you have to almost assess your product every time. And that's really rubbish and that's really time consuming. So what if there was some better fitness for purpose testing? That would perhaps avoid some of the duplication of testing within the industry and give some more confidence about materials. And then we've got our ambition. We haven't really well defined what we want from our lining solutions going forwards. Lots of companies are working on developing new solutions. We've done a technology scan globally, but we perhaps need to say, what do we want? Where is it cost beneficial to look for a new feature or function of a new lining material? And we need to feed that back to the supply chain much better than we already are. And the leakage route map is a great start, and it talks about some of the things we can do, but I don't think we've defined in enough detail for the supply chain that work. The OFWAT Innovation Fund, the Water Breakthrough Challenge, presents a good opportunity for us to do some of this. And I said I'd come back to cost. Bringing a new solution in lining to the UK market is just really expensive. We've been working up a programme with the National Composite Centre, and chatting to colleagues who bring new materials and solutions and installation technologies to market, it's really expensive, it's really difficult, and we as an industry have to provide, I think, a little bit of momentum in doing that, and that's why the OFWAT Innovation Fund is so great. So some of the challenges and opportunities, I'll just go over them in a little bit more detail. So we've got the economy of scale. If we're only doing a little bit of lining, it's never going to be cheap. We've learned on our current lining programme at Yorkshire Water, we don't do enough to make it anywhere near economical, and sometimes it's cheaper to dig a hole, and that's just terrible for customers. I've spoken about Regulation 31 approval. We've got some lifetime concerns about lining technologies that we have. Some of these products, we're told by suppliers, have fantastic lifespans, and it's the lifespan of the material that will pay back for your asset rehabilitation. But if the warranty is only 5 years, that makes us a bit suspicious. How can we push that warranty forwards? And how can we support kind of a testing regime as an industry to give more confidence in lifespan? We then have the ever-present challenge of supply interruptions and cure time. Do we need to engage more with the regulator to talk about how we address that challenge? If we find an amazing lining solution, but it takes 5 hours to install and cure, should we be pushing back against that 3-hour interruptions window? And I've talked quite a little about the UK market not being particularly appealing to suppliers. There's an amazing opportunity in lining though. We used to do loads of lining well before I was in the water industry, and we've kind of lost that momentum, and we need to be thinking about doing a bit more of it. We're replacing a fraction of our network. You know that, it's not enough. When we've been out to water companies and spoken to them, a majority of them want to do so much more lining. And you can either do the same budget and do more of it, or you can reduce your costs and have the same benefits. But we have to sort of stimulate this market. There's obviously carbon benefits that we think we can quantify quite well. Current at-market solutions, we think, reduce carbon by about 70%, and the scope for greater reductions there as well. We always have to think about the customer, obviously. It's why we're here. Big leakage and burst rate reductions, fantastic water quality improvements, and we can potentially reduce other interruptions to supply as well. So there's some fantastic challenges and opportunities to really invigorate the lining market. So Design a Liner is a project that's evolved through a couple of stages. If we think about the 20th century, old pipes, dig a hole, perhaps do a bit of lining for water quality. We then had an UKWIR project in 2021 that was looking at improving the testing approach for lining materials for potable networks. And that was about saying, can we improve things? Do things need to improve? The answer was yes. What our testing and our approach at the moment isn't great. And that really inspired us for phase 1 for Design Aligner, which won £200,000 from the OFWAT Innovation Fund last year. And we've delivered that work with RPS with some support from ISLE. And it was about saying, what do we need from a new lining solution and how can we bring it to market? Not developing a product, just defining a specification, looking at the scale of the market, understanding the challenges. We identified that we really need a product that has a lifespan of at least 100 years because that's where the economic payback is. We've also started thinking about other exciting things you could bring to that lining material, like self-healing materials, embedded fibre, smart networks, biofilm suppression, sensing, all of these fantastic things. And that project is just drawing to a close, and Joe will chat a little about that. As we move into phase 2 of this work, we had a very definite review point in phase 1. Should we carry on to phase 2? Do we actually need a new lining solution for 21st century water network? We've defined that we do. The products we have available to us now are not quite fit for purpose and we need to build upon them. So we're looking at putting another Yorkshire Water-led bid into the next phase of the OFWAT Innovation Fund. And again, Jay will chat about that. I just want to pay credit to the water companies that have supported this work. It's quite a risky project. On the tin, you know, it looks like we want to do an awful lot, self-healing materials, fibre in liners. It's very ambitious. So thank you for that support. The risk is high, but the benefit, if it comes off, is huge. I also want to pay credit to the companies that are supporting us in the phase 2 development. So RPS and their technical support has been fantastic. The National Composite Centre, Graham Jeremy is here at the front to have a chat with him, absolutely fascinating. They are supporting the programme development for the next phase. They're very good at managing large projects and have great technical expertise. WRC are coming on board with their testing capability. And we will have some university academics from the University of Bristol as well to look at some of those more weird and wonderful materials technologies. So I've spoken enough and I will pass on to Joe to have a chat about the programme so far.
Thanks, Katrina, much appreciated. You take a seat, yeah, definitely. So where do we begin? Back in 2019, Jeremy put out a question that said, we want to do some projects really quickly. We want to do them over a summer and we want to get them done really, really quickly. We're going to do some in-person workshops very, very quickly. Then COVID hit and he said, right, okay, we're going to do them online. So for 4 sort of areas, we looked at different things around 2 big questions, zero leakage and also zero interruptions. So doing those, and we gathered lots and lots of data. Many of you in the room were part of those workshops. And the real key one that we want to look at today was very much around the lining. And again, the improvement of the lining. One of the key things that came out of it was that a lot of the knowledge that we have around lining now sits with the supply chain and not in the water companies. There are pockets of absolute expertise within the water companies, but they are normally one person. That is a big, big point of failure. If you're doing a lining project and your person decides to leave to go to a supply chain or another water company who's doing an even bigger piece of lining project. So how do we sort of like move that and make sure it's there? The other thing that we sort of found was that there is very much a limited UK market, as Katrina said. Mains renewal rates are pretty low, lining rates are even lower. However, people are saying, if we could do lining cheaply, we would do more and more of it because we can see the benefits of it. We can see the benefits, we just can't make the business case because of things like the 3-hour interruptions. These things just do not cure quick enough so that they can do that. Or if you've got sort of like a tubular liner, then potentially that means that you've got to go and cut out all the supply pipes. So that makes it not cost effective because you've got to dig down all of those. We might as well put a big pipe in anyway, proper full polyethylene pipe. So there's lots of things around that. And again, the supply chain, the water companies, all of them wanted to sort of share and bring that data together. And so that got us thinking of like, well, where do we take this next? Just at the same time, the OFWAT Innovation Fund came along. And again, not our slide, but thank you, Ian and OFWAT for this. But I thought I'd just introduce, for those of you that don't know, what the OFWAT Innovation Fund is. It's 200 million quid that we can use as an industry to progress in innovation, to make things better. There's been 3 innovation sort of sessions so far, and there's another one starting at the moment. 41 projects, and they are all absolutely fascinating. And again, I probably, with my researcher hat on, I'm going, oh, I want to be involved in that one. And they are just great ways of pushing forward work, not only the supply chain collaborating together, but all the water companies collaborating together as well. And again, I think that's really key that sort of 23 out of 25 water companies have been part of at least one of these projects. 63 million awarded so far, hopefully some more being awarded by the end of February, which I think will be fantastic. So in phase 1, we went for what's known as the Catalyst. This is the little project. And we went, right, okay, so what's out there? Does there something that fits the requirements of Design Aligner? So as Katrina said, we got our colleagues at R Utilities. They did a fantastic technology scan and lit review. They found lots and lots of different bits and pieces that were all over the place. So again, they reviewed 36 odd technologies and different cure-in-place sort of things, 27 suppliers across the world. The one bit that really gets me is that only 6 of them were in the UK. 6 of them were UK based, the rest of them were across the world. And we've actually found some more now in Australia. And Monash University have done a lot of work on this, as have the likes of Texas A&M, I think it is, over in the States as well, and really sort of like 2 really big places where they've done lots of work on lining and put out lots of literature reviews. So do you actually make spray liners a bit like concrete, where you actually need to put a sort of a support structure in to make it last longer? Or do you have a tubular thing that actually there's a little robot that comes along and pops the holes as you go through for your supply pipes? We also quantify the UK market. So we sent out a survey to a lot of water companies and they said, yep, we'd love to do a lot. And in AMP8, we need to do a lot. So definitely that sort of UK market is there. And we also sort of asked what are the requirements of these things. And again, things like warranty came up, as Katrina said, things like lifetime, things like added benefits, water quality, how do we sort of push these forward? Ability to sort of be done within a 3-hour window, if that's what's required by the OFWAT guidance. We're now putting together those requirements into a specification that can be sort of like there, and we can almost use that going into phase 2 as the key document. And we also then looked at everything that was on the market to say, right, okay, what's the requirements that the water companies have said and that we sort of stated, and does anything meet that? And at this stage, no, nothing does quite meet that, and hence, as Katrina said, we're pushing on to phase 2. So phase 2, we sort of bulked up the team, got together a bit of a bigger gang, and as Katrina said, National Composite Centre are along with their fantastic test facilities over in Bristol, WRC with their sort of work that they've done, and again, Leo Carswell can't be here today, sort of helping with his work that he's done on this type of area. Ourselves, Bristol University with their Composites Institute, again, some sort of big hitting professors to do it, and again, Yorkshire Water leading it. As Katrina said, these things do not come quickly or cheaply. To design and take molecules to pieces and put them back together and refit them and make sure that they are what they need to be takes a long time. It takes a lot of research, takes a lot of thought, takes a lot of testing. You've got to do long-term testing as well. And again, so that means that approximately 3.5 years, might be a little bit less, might be a little bit more. We're just sort of finishing the exact timescales. Again, it's not cheap. These things take a lot of time to sort of think through, and the test facilities that we're using won't be cheap to sort of test these things through, so that we can understand how they react on a long term. So at the moment, the budget is approximately £4 million. That might again increase. This is just sort of like ballpark figures at the moment. And again, we will have a final sort of value very, very soon when we put it in the innovation. So, what are we expecting in phase 2? So as I said, a 3.5 year sort of project. We're just getting the partner support sorted out now before Christmas, and we'll put the phase 2 bid in just after Christmas. And as a sort of a well-behaved catalyst piece, we were able to skip the first part of the transformational stream submission. So we've gone straight into the second phase, which is fantastic. And I think a really good innovation from OFWAT of moving forward of like, well, actually, yeah, you've already done part of it. You've already done like your phase 1, like go straight through to phase 2. We're then going to go through a thing of, as I say, these future technology views. So do we want suppression of transients? Do we want biofilm suppression? Do we want fibers in the lining? Do we want structural reinforcement within the lining? Do we want the lining not to be made of oil, which is a key one? This thing has to be sustainable. This is the 21st century liner, not the 20th century liner that is just rolling over to the 21st century. This thing has to be massively future-proof. So again, does it have to be oil-based? And this is the stuff where the guys at Bristol are going, oh, well, we could synthesize it here and synthesize it there. And we had a chat yesterday morning, almost made us miss all of our trains to get here for yesterday. But in the end, we sort of said, yeah, okay, this is the sort of things we need to go to. Once we've selected those materials and all the added features, we sort of then need to sort of like put it together. And then literally this is molecules being broken apart and put back together, as I sort of said. We then need to do materials testing. So this is at a sort of a much lower scale, just sort of almost painting it on old bits of pipe, pulling it to pieces. Does it bond to the pipe? Does it not bond to the pipe? Lots of different tests. And all those of you that are aware of lining, again, is it meant to sort of bond to the pipe? Is it not meant to bond to the pipe? Is it fully structural? Is it non-fully structural? All of these things will sort of be there. Then we're going to build bigger tests to sort of make sure that it all works at that bigger scale, and also demonstrate that this can be sort of put through in an easy way, can be cured in an easy way, and can sort of meet all the requirements. So that's phase 2. I'm going to hand back to Katrina now for the final bit of how to get involved.
So, as I've said, we were delighted with the support for phase 1. If you're a water company supporting that, thank you very much. Phase 2 is clearly a lot more ambitious, both in cost, duration and scale. If you'd like to support this project, I would really like to hear from you, as would Joe. Please drop us an email. If you email me, you will be directed towards whoever my cover is. 1- and 2-page summaries for both, 1-page summaries, sorry, available for phase 1 and phase 2 if you just need some more details to share with colleagues, or perhaps you need to get internal approval. We are here to talk about these projects and we need your support to make this successful. If you're part of the supply chain, we definitely need your help to make this project successful, but we would find it very difficult to accept your support at this stage to put onto the bid, because we want to have that flexibility to select partners carefully from the supply chain as we move forward based on chemistry, performance, what we need out of these materials. So we're not ignoring you, you are really important, but at the moment it's the water company support we need to see, but please do talk to us. We will happily answer any more questions. Graham is here from the NCC as well, who will be able to talk about any concerns you have about the programme and any risks. Otherwise, I will pass over.
And we'll do questions at the end for the...
Absolutely fine.
Well, good afternoon, everyone. I'm Ian Robinson, and I'm going to talk to you a little bit about in situ resin spray lining. I'm guessing that probably there's a few people in the room who might have some knowledge about in situ resin lining, but I'm also guessing there's probably a fairly substantial number that know absolutely nothing about resin lining. So if I do my job right, hopefully you'll all go away knowing a little bit more than when you came in. So I'll just skip through briefly what I'm going to talk about. So I'm going to do a very brief history of resin lining. So where we've come from and up to where we are now. Katrina and Joe have already talked about where we might be going to some degree. I'm going to talk a little bit about classification of linings from a structural perspective. I'm going to talk about some of the capabilities, limitations of spray lining, and just touch on some aspects of lining design in terms of lining installation and designing them for lining schemes. Quickly through some benefits in comparison to pipe replacement, and I'm going to wrap up with a brief case study from Yorkshire Water and some conclusions. So, what is in situ resin lining? Well, basically, it's the application of a two-part thermosetting polymer, which can be epoxy resin, polyurethane or polyurea, to the internal surface of an existing pipeline infrastructure. The polymer is applied as a liquid. It's applied via what we call the spin cast technique, and the polymer hardens at the ambient temperature of the pipeline. So generally there's no external, no application from an external heat source required. The actual setting time of the material will be determined by inherently by the polymer type, but also by product specific formulation characteristics. Okay, so here we have a schematic of the lining of the lining process. So hopefully you can see on the right of the slide, you've got the lining rig. We've got two excavations and the length of pipe between the excavations. Typically, the length of pipe that can be lined would be normally minimally 50 metres, but could be as much as 150 to 200 metres. It's largely determined by the way the network's configured and whether you're working in urban or rural locations. So the main components of the lining rig are two reservoirs, which house part A and part B, which constitute the polymer. And you can see hopefully see a rather large hose drum and winch, which houses what we call the umbilical hose. So the umbilical hose contains two individual hoses, one for part A of the polymer, one for part B. It will also contain a heating element, and it will also contain a compressed air line, which powers the application head for the application of the polymer. So the umbilical is connected to a static inline mixer. So the two components travel down their individual hoses in the umbilical. They're brought together through the static mixer, fed into the lining application head, which is powered by compressed air. The application head rotates at about typically 8 to 10,000 RPM and sprays the polymer onto the inside of the pipe. And that's all happening as the lining head is being winched back through the pipe towards the lining rig. Okay, and there's a very pretty picture of a very up-to-date resin lining rig. So if we look at the history of lining in the UK, I probably suspect there's no one in the room old enough that can remember the early efforts with lining pipes with epoxy resin back in the 1980s. Does anybody remember dear old Mercol Geopox, which was the first epoxy which was used in potable water mains? But by the end of the 1980s, when we entered into AMP1 in the 1990s, the use of epoxy resin for lining potable water mains had actually become very popular. And through the AMP1 and AMP2 periods, there were some pretty substantial lining programmes undertaken. Thames Water did an awful lot of epoxy lining, as did Yorkshire Water. So it really became the preferred method for rehabilitating pipes which were suffering from or exhibiting water quality compliance issues. So of course, in the wake of privatisation and the advent of the European Drinking Water Directive, a lot of work was required to bring drinking water up to the standards of the day. So, awful lot of epoxy resin lining carried out during the 1990s. However, one of the principal drawbacks with epoxy resin lining was that actually the supply had to be turned off for 36 hours. So this was to allow for cleaning of the main application of the epoxy resin, but then there was a minimum 16-hour period during which absolutely nothing happened. So the epoxy resin had to be left overnight to actually harden, and then the following day you could set about disinfecting, flushing the main, disinfection, flushing the main, and return to service. So there was a period of 36 hours when nobody had any water. Now, there was something of a seminal moment in the industry in 2000 when the E. Wood Company, based in Northallerton in North Yorkshire, launched the High Court 169 product, which was known, which at the time was christened the rapid setting polymeric lining, which was actually a polyurea product utilising aliphatic polyisocyanates. And basically that material hardened in 2 minutes. So it meant that all of a sudden, all that dead time associated with the curing of epoxy resin had been eliminated. So it meant that mains could be rehabilitated, returned to service, all in the same day. Now, fortuitously, the launch of that product coincided with the commencement of AMP3 back in 2000, and the concept of rapid setting polymeric lining was wholeheartedly embraced by some water utilities, specifically Yorkshire Water and South West Water, and they did huge amounts of spray lining during AMP3 and AMP4. In fact, in the UK, there were over 5,000 kilometres of mains were rehabilitated using this material. Now, those programmes largely came to an end around about 2007, 2008, as AMP4 wound down. And then since then, there's really been something of a hiatus in spray lining activity in the UK, other than some lining which went on, which was taking place in Scotland as they kind of caught up with their water quality driven programmes. So that brings us right up to the present day in AMP7, and there is a new material, a relatively new material available, which was launched at the beginning of this year in the UK, which has suitably validated structural properties. So that opens up a slightly different space to the compared to the historical lining activity which has taken place in the UK. So if I just expand on that statement about the structural capability of spray liners, ostensibly all the lining programmes that were undertaken historically were undertaken on a non-structural basis. So the host pipe was assumed to be structurally competent, and that the pipe just needed a heavy-duty corrosion protection coating for water quality purposes. So those linings are referred to as non-structural. There are a couple of documents which provide definitions around structural capability. One is the American Waterworks Association M28, which is actually a water mains rehabilitation manual rather than a product standard as such. And then you've got the BSEN ISO 11295 standard, which is actually a plastic pipes standard. So of the two, I generally make reference to the AWWA M28 rehabilitation manual. Okay, so then we move on to what can be classified as semi-structural liners, or perhaps more accurately described as interactive liners. So those are liners in which the internal pressure load is transferred via the liner to the host pipe, except where there may be local damage zones in the host pipe. And it's at those points where the liner itself acts as the pressure containment. Now, there are two classes of semi-structural liners, class 2 and class 3. Simple difference between the two being that a class 2 liner relies on adhesion to the host pipe, whereas a Class 3 liner doesn't require adhesion. It's got sufficient hoop stiffness to be self-supporting in the absence of adhesion. And then finally, we have structurally independent liners, which some people refer to as fully structural, which are the Class 4 per AWWA M28, or Class A if you prefer the BSE and ISO classification. So, what are the capabilities of resin lining? Well, first and foremost, it enables the restoration or the enhancement of hydraulic capacity. That was very evident in the in days gone by with the water quality driven programs that took place, that remains heavily tuberculated. There's a loss of hydraulic capacity. If it's cleaned and spray lined with a smooth polymeric liner, then the hydraulic capacity is going to be restored or enhanced. I've already touched on maintaining water quality compliance. Generally, that's things like discoloration or iron and manganese levels. It's generally assumed, and experience tends to bear this out, that once a main has been spray lined, that internal corrosion is effectively arrested. Obviously, you can't do anything about external corrosion, which can continue apace in some circumstances. So those aspects are really apply to linings generally. When we move into this semi-structural or even structurally independent space, then the lining can provide, as I mentioned, spanning capability at local damage zones for the lifetime of the rehabilitated system, or in some cases the lining can be designed to act as the primary pressure containment rather than just to act in spanning mode. So if we move on to some design considerations for the liner. Now, when I say design, I mean the actual installation of a liner. So if we've got a scheme, if there's a scheme that's a candidate for lining, how do we design the lining in terms of thickness? So some pertinent questions. Fairly obviously, what's the main constructed from? Different materials of construction fail in different ways. For example, small diameter cast iron mains generally fail quite differently to ductile iron or PVC mains or even asbestos cement mains. What mode of action do we want to design for? Are we talking about simply voids? Are we simply talking about spanning at local damage zones? In which case the Timoshenko plate theory applies. Don't worry, I'm not going to go into that or even start producing any equations. If we want to design for the liner to be the primary pressure containment, then Barlow's equation is applicable. If we're designing for spanning, does the lining need to adhere to the host, or can it be self-supporting? I'll come on to one very important point. Joe and Katrina have already alluded to sort of material properties and lifetime of a liner. In designing a liner thickness for a particular scheme, then it's absolutely imperative that the material properties which are used for the basis of the design are time corrected. I've seen some examples of, shall we say, extremely dubious practice, not in this country, I hasten to add, where suppliers of materials are quoting dry material properties, short-term properties, so no allowance for long-term immersion in water, no allowance for creep, and are simply applying arbitrary correction factors to short-term dry properties. It's just fundamentally bad science. So if anyone's considering using a lining material, ask the supplier to provide you with their time-corrected data. And finally, what design life, which again Joe and Katrina have alluded to, what design life should be applied to the design? Is it 30 years? Is it 50 years? Is it 100 years? And what factor of safety might you want to apply? Okay, so that's everything that's good about resin lining. So what about some of its limitations? Well, the first thing is that resin lining cannot be guaranteed to provide a completely seamless end-to-end solution. Yep, okay. So it may or may not survive catastrophic failure of the hose pipe. And the lining thickness required could become prohibitive in larger diameter pipes, especially if you're looking at designing the lining to act as the primary pressure containment. Okay, now some of the benefits of lining against pipe replacement, fairly obviously, there's much less digging required. If you've got less holes, you're on site for a shorter period of time. There's going to be less in the way of traffic management to deal with. Significantly reduced carbon footprint, possibly up to as much as 60 or 70% reduction compared to plastic pipes. Greatly increased productivity and lower costs compared to replacement. Now, are there some barriers to adoption? Yes. A lined pipe will be a rehabilitated pipe. It's not a new pipe. The 3-hour service interruption metric, that is a barrier to lining. If the main's heavily tuberculated, very difficult to clean a main, line it, disinfect it, flush it, return it to service in 3 hours. There may be some inherent resistance to lining within a utility. It might be that, well, we've always just replaced pipes, and so that's what we're always going to do. And the issue of knowledge and experience lost from the industry. A lot of the people that I've known over the years who know and understand lining have either retired or sadly no longer with us. So finally, just to wrap up, if we go onto this, onto a very recent case study from Yorkshire Water and working in partnership with Morrison Water Services and Resiline, the company who provide the lining material. So this involved 10 kilometres of distribution mains, quite widely scattered through South and West Yorkshire, from Tadcaster in the north down to Sheffield in the south. Typical distribution mains, 3 inches to 6 inches diameter, fairly standard operating pressures. So the material which was used was Resiline 320. These linings were all designed to be class 3 semi-structural linings, so self-supporting and not reliant on adhesion. All designed with a 50-year design life, and the assumption was that any corrosion voids forming post-lining, so as a result of ongoing external corrosion, would not exceed 25 millimetres diameter. A factor of safety of 2 was applied to the design, which resulted in lining all of this being able to be accomplished with lining thicknesses ranging from 2 to 2.8 millimetres, which could all be applied in a single pass of the lining head. So, according to Morrison Water Services, they achieved the benefits that that were accrued in comparison to replacement. Very significant reduction in the time spent on site. A meaningful reduction in carbon and a good reduction in cost. Now, because of the geographically dispersed locations involved, then from a cost perspective, I'm pretty sure that scheme wouldn't have been as cost effective as other schemes where you've got a much higher concentration of mains in a smaller geographical area, but still a meaningful reduction in cost. And finally, an enhanced customer experience compared to replacement. So to wrap up, resin lining's come a long way in the last 40 years. There is currently a new material available which offers interesting and appropriately validated structural properties. Spray lining can provide fit-for-purpose outcomes, albeit it doesn't provide a new pipe. But there are significant societal, environmental and economic benefits in comparison to replacement. But going forward, I would suggest that there is some process development needed so that lining can provide a totally seamless end-to-end solution, which is not potentially disrupted at joints in the pipeline, which has been rehabilitated. So I just close by thanking Jeff Hopkins from Resiline and Liam Sadler from MWS for their help with the case study detail. So thank you very much.
Thank you. Brilliant. Good afternoon, everybody. I'm what's standing between you and a plate of pasta in a few short minutes. So if you'll stay with me and keep the blood sugars high for this next 15 minutes and then some questions, we'll have you on your way. Today I want to talk to you about something a little bit different. It's not a liner. I want to talk to you about Hydroseal. Again, an innovation in MEND, like we've heard from previous presenters, and they've sandwiched me in between MEND and background leakage, and that is very apt. My name's Leon Fern. I work for Hydrosave. I'm the head of strategy and projects. Right. Here we go. We have the technology. A little bit about Hydrosave. Most of you will know us as a leak detection company, but we are specialist leakage management, pipeline services, and an asset management business. So focused on keeping critical infrastructure flowing, reducing leakage, and providing innovative and practical solutions. Our group, so Hydrosave is part of the South Staffordshire PLC group, so a larger group. Within South Staffordshire PLC, we have the regulated businesses of South Staffs Water and Cambridge Water, so water-only companies, but we also have engineering businesses within our non-regulated arm. That includes on-site specialist contracting, IWS, water hygiene, and mechanical and electrical. So, what is Hydroseal? Hydroseal is based on Curapipe technology, so developed in Israel with Israeli government funding and EU funding, but it's a targeted low-dig background leakage solution. Primarily a main side solution, although it can be used for larger private pipe work and longer supply pipes as well. What does it do? It creates small surface area repairs. It's not a liner. It can be used on all of the different pipe materials, and it can be used on the different types of leaks, whether it's pinholes, joints, longitudinal cracks, splits, circumferential breaks, displaced O-rings, seals, or failed joints on PE or asbestos cement pipes. How does it work? It anchors and it bonds to create that bond at the leak site. The testing so far out of Israel suggests a 10-year asset life, albeit some of our testing suggests that it could be as much as double that as well. So the benefits of this method, this type of method, we believe it's a cost-effective solution to reducing background leakage. It complies with Reg 31(4)B, small surface area. In one deployment, you can seal multiple leaks. We believe there's a reduced health and safety risk when compared with traditional excavation methods. And you can treat hundreds of meters in a single day, giving us, as an industry, an early opportunity to seal weeps and seeps before they become worse. And after the deployment through the pipe, it is structurally sealed within 90 minutes. One of the other benefits for this is that the deployment process itself allows you to monitor how much leakage you've got on a section of pipe before you've put it in, and you can see through the flow monitoring and the pressure monitoring, you can see actually what you've fixed during the deployment. So it's real loss leakage saving. Thank you to Stuart Troe, who's not here today. Steve said it was okay, so thank you, Steve. I think we're all sick of seeing icebergs now, but I wanted to make the point that this is a background leakage solution. So we all know visible leaks, we can see those ones. Active leakage is what our teams and your teams find day in, day out. This technology is focused on the background leaks, so the stuff that's too small to be found with current technology. Effectively, we're looking for sections of pipe with at most 0.06 megalitres a day of real loss leakage on. That's what we're looking for. How does it work? Well, put simply, we need to get it in, we need to know where it goes, and we need to get it out. Deployment runs are typically 150 metres, but this is largely determined by the volume of leakage on the pipe, the route of the network, and the number of laterals, so the ferrules and the compipes that come off that section of main, and any overland supplies that are required to keep customers in water at the same time. So we launch upstream. In a DN 100 or 4-inch, we launch at 2,500 litres per hour plus 500 litres an hour to create a pressure differential and flow through the pipe. And ultimately, it propels the pig train. So that's a 3-part pig train with the secret sauce at the front, the active repair material, fibres or chips. So that's enough of me talking. What does it look like? So, welcome to Trent Valley, our rig just 30 miles north of here. You can see there a see-through section of pipe with a leak on the side closest to the bottom of the screen. There we can see the pig train move, or the front of the pig train moving through that section of pipe, curing the leak as it goes. That's the carrier fluid with the active repair material, what I like to call the secret sauce. These ones are the fibres, not the chips, but if we've got a particularly persistent section of pipe, we can put the chips through as well. And there's a video of those on the stand outside. The video will speed up in a second and we'll see the first of the 2 propulsion pigs. The first one, a low viscosity gel pig, and then behind it, the second pig, a high velocity gel pig. In the real world, we would flush afterwards 4 times pipe volume or 8,000 litres an hour. Great. So here we have a collection of pinhole leaks and a split. We can see the carrier fluid going through and curing those leaks as it passes. I thought at a leakage conference we should have some videos of leaks running, just remind ourselves. Great. This is my least favourite video, showing a very slow seal of a joint leak. But again, a benefit of the technology, it gives you that early opportunity to seal weeps and seeps before any leaks get worse. And indeed, many of them in one go. And we can see the leak getting fully sealed. Okay, there we have a collection of pinholes of different sizes. So on the far right, we've got one that's 1.5 millimeters, and on the far left, we've got 4.5 millimeters. And what we can see again is the carrier fluid, the fibres, curing those leaks. It does take a bit longer to cure the larger leak. I shall help myself in the meantime. what we can see there is the propulsion pig coming through behind on the 2.5mm hole, but because there's a little bit of mixing between those two parts, a fibre gets into place there and just cures it afterwards. Brilliant. Here's a com pipe or a supply pipe, and we can see pinhole leak there. We can see the hydroseal curing that. Fantastic. So a little bit about our journey. So our innovation journey is very similar to what Andrew presented earlier as part of the Wallingford Test Centre. We've taken a risk as HydroSafe. So this is pre-OFWAT innovation funding. It's pre-spring. It's pre-Leakage Innovation Centre. Why have we done this? Well, as a business, and indeed as people, we're passionate about innovation. This is about spotting an area within the market that we think needs further development, and we thought our skills uniquely combined, and we could bring this to the UK. Interestingly, on the innovation front, it was I was talking to Joe last night about this, but it was HydroSafe that introduced lift and shift noise logging in the early 2000s. I know we've just celebrated our 25th anniversary, and it was very much part of our LinkedIn update. But we acquired the license in 2018 for the Cura pipe license in the UK. That's UK and Ireland. We got DWI Reg 31.4B, small surface area, a few months ago. And basically, we're at alpha stage at the moment. We've completed a lot of the R&D. We want your views as water industry professionals. We want you to come and tell us some of your problems and whether this might be able to help you. So we're looking for partners to pilot it on real-world assets in the UK. We have the materials and the experience within HydroSave and the wider group, and we can work alongside your teams as well. So compliant to Reg 31.4B and certified to BS 6920, and that's the active repair material. So internationally, this isn't new. We've had 250 plus deployments worldwide. So in Italy, that's had 100 pipe sections treated, so that's multiple pig trains. The specific case study of Brescia province, I hope I'm pronouncing that correctly for anyone who speaks Italian. We were looking for 0.25 MLD leakage on that section of pipe, and Cura pipe found in that example 100% of that. In Italy, generally they found about 92% of the leakage that they were looking for. South Africa, similar picture. 100% save, 0.2 MLD, and we've also had an installation in Jerusalem Old City in Israel as well, where the technology's from, and that delivered 87% of the lost water that they were looking for in that area, so 0.6 meg. But there are challenges with this. So you know, we have to choose a DMA with high background leakage. So that's not high burst frequency, that's high background leakage. And we know there's a large amount of feasibility and planning involved in this. This isn't sort of an R&M style solution. We need to ensure we're in the right area. And again, we've got the process lined up and it proceeds as planned. So there is a large amount of feasibility and planning. The process allows us to differentiate between what is main side and what is customer side leakage. So whilst we're on site, we can determine which it is, whether it's main side or customer side. And depending on the synergies with other programs within the client water company, there could be a large amount of enabling works required. So whether that's boundary boxes, OXOs or line stops, and indeed there's a lot of chlorination and flushing involved as well. And we have to keep everyone in supply during treatment, or that's our working assumption anyway. A large amount of water is used during this process, so we flush with 4 times or 8,000 litres, as I said earlier. One of the biggest challenges is this is new in the UK. You know, it's a new product category in the market. I know there are a few of us in this space, but it's new, and we need to take that leap in real-world deployment. But what we do as a room has never been more important, and it's never been more high profile than it is now. So I'm not going to go through this process, but I was conscious that the materials are shared afterwards, so I thought I'd include it anyway. Really, I wanted to conclude by saying we know when to use it, we know how to use it, we know the process for getting it in and out of the system. We know that water companies have synergies with, for example, metering programs, and more boundary boxes are going in, hence the enabling cost comes down. We have the experience ourselves within HydroSave and our group to make it happen. Alternatively, we can work with your teams to make it happen. But we are at alpha stage. We need your help. So we're looking for interested parties and partners to help us take it forward in the UK. We have begun talking to a number of water companies, including our existing leak detection clients. Can I just, before I say thank you for listening, can I just ask George Miller and Stuart Williams to stand up, please? We have got a stand outside, so please do come see us, come talk to us, but the gents there, thank you, George, one at a time. Come and speak to us, and yeah, thank you for listening. Thank you. 15 minutes.
So while you tidy up the cards on the floor there's been quite a few questions come through on Slido here, so I think this is going to be, we're a bit behind time, and I think there's probably going to be quite a lot of questions from here as well. So quick answers, if you wouldn't mind, quick fire answers. So Ian, can you comment on the longevity of spray liners as against mains replacement and the cost differential?
Okay, longevity. I mean, historical studies have shown that even the old epoxy liners had a useful working life of 30 to 50 years. The more modern rapid setting polymeric liners exceed epoxy resin in terms of durability. So the 50 year design life should not be an issue for a correctly designed
50 years broadly.
Correctly formulated and designed spray liner as a minimum. Could be longer.
Is there any lining repair options for customer side leaking supplies? I think we did hear a bit about that in Liam's presentation, and something I've thought of is that lead replacement or curing the lead problem, shall we say, is a hot issue in our industry now. Any comments on that?
Just that I agree with you. It is an issue. It's something that, again, you know, we can do camera surveys ahead of the deployment, and it's something we can identify up front. It's part of the feasibility planning. It's not, you know, you have programs already, and we need to synergize with those programs.
But yours is a repair technology rather than a replace the pipe or reline the pipe technology, yeah?
Yeah, it's a small.
I think that the DWI have recently said that they would not heartily endorse lining of lead supplies.
Yeah, I know that is their basic position, isn't it? Yeah.
And that's a very difficult one for us to overcome then.
Yeah, okay.
I think the issue you've got with that is, of course, that the utility isn't responsible for the supply pipe. So I mean, Yorkshire Water did a few years back. Yorkshire Water lined quite a lot of lead pipes, but they didn't line the supply pipes for obvious reasons. So if you've been monitored on lead at the tap, but you've only lined the comms pipe, there doesn't seem to be much. You know, you've still got all the lead in the consumer's property.
So there's a question here about the 3-hour window, which is an issue in terms of interruptions to supply. Should OFWAT consider this target for these kind of projects?
Yeah, I think so. I think that they should bring innovation in to make sure that but at the same time, you have got vulnerable customers, like, as I say, people on dialysis. Being off water for 10 minutes is a big deal for those sort of people. So do we need to modify that and say, okay, well, actually, it can be up to 8 hours for normal people, but if it's on a vulnerable customer, zero minutes. Like, you have to make sure that there's a supply there. So that would then drive different innovations, which I think would be positive. So
perhaps drawing a distinction between planned and unplanned might be very helpful.
Yeah.
If you,
Okay, and a couple more. Well, interesting question. How much does HydroSeal reduce background leakage?
Great question. Up to 100%. However, it's about the the real loss quantification at the start, and then you can see how much of it you're fixing. So that's not the same as saying that an area DMA, for example, has estimated leakage of X, and we're reducing 100% of that. Yeah, that's not the same as that. It's just
the challenge is finding the bits of pipe on your network that have got the high background leakage.
You got it. Yeah.
Okay. All right, one more. Why has HydroSeal been so slow to bring to market?
Thank you, whoever that was.
A bit controversial.
It's a great question. I know the product was redesigned to be gel pigs rather than foam pigs. It's taken us a while to get through the sort of DWI testing. That's a couple of years. Everyone sort of nodding on the panel. It has taken us a while.
Okay.
Yeah.
Any questions in the room? I'm sure there are a few. Are we taking them all up on the... No. Everybody's hungry. Well, in that case, I'll draw this session to a close. Thank you to all of our 4 panelists for 4 great presentations, or 3 great presentations. And please join me in showing appreciation. Thank you. So we've got an hour for lunch, I think. So we're a little bit behind, but back here for 2, and Peter is going to take you through the afternoon. Thank you.